Okay, so stem and leaf plot. Remember the basic stem and leaf plot had a stem, which was the main number, like the tens power, and then all the leaves were the ones. Well, a two-sided stem and leaf is also known as a back-to-back stem and leaf. And what this does is it compares two sets of data. And it's discrete data. Okay, and what you have is you'll have the leaves from one group, the stems, and then the leaves from the other. So for example, if like I had my stems were 0, 1, and 2, I could have like 2, 2, 3, 5, and then you go backwards on the left. So instead of being 2, 2, 3, it would be like 1, 1, 3, 6. So you always start with the smallest number closest to the stem and move out. So with like a regular stem and leaf plot, you've got like a one-sided tree. With a two-sided stem and leaf plot, you have a two-sided tree. Well, remember when we did the original stem and leaf plot, we did all the numbers first and then we put them in order? So you do the same thing, only on this side you go in order the other way. Yeah, no, it is. It's a little bit, it takes a little bit of getting used to. So like, you know, we could have stuff like that. And so you have two sides. And so this is all the numbers from group 1. This is all the numbers from group 2. And it's really nice because you can see quickly, like, here, what? 2, 3, 4, 5, 5, oops, I meant 7. Yeah. So this is 12, 13, 14, 15, 15, 17. And here I have 13, 15, 16, 16, 17. And then if I have like some numbers over here and no numbers over here, it's really easy to see like this group has 20s and this group doesn't have 20s. This group has more teens than this group. I mean, it's really easy to make those side-by-side comparisons, you know, just for like the numbers in categories. Any questions about kind of what it looks like? Because we're going to build one. Now, because I normally like to make one and then fix it, I'm going to go ahead and add a blank page to this. And so we're going to start it here and then we'll finish it on the next page. Okay, so we have girls and boys in a high school AP English class, and they're having a contest, and they want to see which group can read the most books. Yay, reading. Okay, so she's tallying the number of books for each group, and so we've got all the girls and how many books they read, and all the boys and how many books they read. And hey, look at this. I already put them in order. See how nice I am? Yeah. Probably the next one's not. Okay, so we do the stem in the center. And then we decide, we want boys on the left and girls on the right, or girls on the left and boys on the right? I have to make the line straight. I can't. Well, we'll go alphabetical. How about that? So if we go alphabetical, boys is here and girls is here. Okay, and here's our stem. So we have our smallest number is 11 and our smallest number here is 15. So we don't have to have a 0. We can start with a 1. And then I have 2s, 3s, up to 5s. Okay, so for my girls, I have 11, 12, 12, 17, 18, 23, 23, 23, 24, 33, 34, 35, 44, 45, 47, 50, 51, and 51. Now for my boys, I go backwards because they're on the left. So I have 15, 18, 22, 22, 23, 26, 34, 35, 35, 35, 40, 40, 42, 47, 49, 50, 50, 51. Okay? If you do this on graph paper and put one number per box, it looks a lot neater if you want it to look neater. So here we go. We have the mode for each group. The girls mode, I've got 3 23s. So 23. And for the boys, I have 3 35s. So who won the contest? It depends on who read the most books, right? Well, we have an equal number of numbers. We can see that the boys have a higher number of high numbers. So I don't even have to count up the total number of books. I can just see that the boys have more 30s and 40s than the girls do. So they've read more books. So the boys won the book contest. Okay, so we're going to do another one with AP Statistics. And she has a current grade 12 class, which is 2010, and we're going to compare it to 2009. So I'm just going to put them in order again. You don't actually have to write STEM in the middle. I just do it for the notes. I'm going between 70 and 100. So 7, 8, 9, 10. Okay, your leaves are always a single digit. So if you have a 3-digit number, your STEM is 2 digits. So, and if we went like 110, we'd have to have an 11. Okay? And then, you know, we're again 70 to 90, so we're good. So the 2010 class, I have 3 zeros, a 1, a 2, 1, 2, 3, 4 fours. I'm going to run out of room. A 5, 2 6s, a 7, an 8, and a 9. Whew, made it. Then I have a 0, a 1, 1, 2, 3 2s, a 3 and a 4, 2 5s, 6 and a 7, and then I have a 93 and a 98 and a 100. With the boys, I have 4 6s, a 7 and 3 8s, yeah, 3 8s. 3 8s and then a 9. And then I have a 2 zeros, 2 2s, 2 3 3s, 2 5s, and an 8, and then a 1 and a 5. Okay, so we can see that the 2010 class had more lower grades, but also had higher grades, right? So they had more individually lower grades, but they're the only class that had 100, and then they had, you know, a 98. You can see that 2009 had no hundreds. The highest was a 95. I would say class average for 2010 is probably lower because we have 76s and 78s in here, but here I have 70s and 71s and 72s, which is going to bring that class average down, even though we have the 100. You know, just things like that that we can look at. The mode for this one is 74, and the mode over here is 76. So since mode is also a measure of central tendency, you can say on the whole, probably 2009 did better than 2010. Individually, 2010 had like a couple stronger students, but you know. So but see how like we were able to figure all that out just quickly, easy, without having to calculate the averages, without having to count totals. We just looked at it and said, oh well, look, these numbers are more than those, and that means, you know. So that's why these are nice. Because it makes it so that you can make conclusions about the data without having to do all the calculations. Did you see what I mean? which is nice because it saves a lot of time. All right. We have males and females, and here I did not put it in order. Okay, man, woman, man, 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 woman, man, you know, so we're going to have a lot of organizing to do. All right, so did I give myself a blank space? No. All right. What I'm going to do is I'm going to start by separating males and females into two lists to help start to organize this thing. Or we can start making a stem and leaf and then fix it later. Okay, so we'll start making a stem and leaf and then we'll organize it when we're done. Okay, so I have males and females. Okay, the smallest one I have appears to be in the teens. Yeah, they're not in order because I've got 50s over here and 60s up here, but it looks like 70s is the highest I go. I don't see any 80s, so I need to go from 1 to 7. And since we're so tight on that, I'm going to go ahead and put lines in between just to make it easier for us to keep this organized. And you can, if you want to have lines in your stem and leaves, you can. There's no rule that says you can't. Most people don't, but like if I'm actually constructing a stem and leaf for, you know, like a reason, or to turn in for when I was in statistics class, to turn in for like a homework assignment, I always put them on graph paper because I liked the organization of having one number per box, and to me that looked really, you know, nice. So it's up to you. All right, so we have 2 for the male, an 8 for the female, a 15, a 5, a 10, 21, 25, 21, 26, 29, 29. And I'm going to pause the recording right now because we've got all these numbers, but we need to put them in order because they have to be in order for it to work properly. So I'm going to come over here and make another stem and leaf plot that's and I had 1, 2, 3, 4, 5, 6, and 7. Okay, so then we'll just bounce back and forth. For the males, I have a 0, a 5, and a 2. So again, I have to go lowest to highest out away from the stem. Oops, wrong direction. And then I have an 8 and a 5, so that's 5, 8. And then 1, 5. And 1, 6. Oh, actually, that was in order. That's kind of nice. 1, 3, 5, 5, 5. In order again. What was it? 2, 5. And then 1, 2, 6, 8. And then 1, 1, 6, 8, 9. Whoops, wrong direction. And 5. And then 0, 5, 5, 6. And 0, 1. And 2. And then 0, 0, 1, 1, 2. Okay, now looking at this, obviously, okay, so what we were talking about is ages of people who entered a new hardware store within its first half hour. It's a new hardware store. Are you guys surprised that there were more men than women? Yes. Good for you. No, more men go to this is reality. More men go to hardware stores than women. Yes, but it's grand opening of a hardware store. The tools are on sale today.
I'm impressed with a 72-year-old woman.
I know, she's impressive. Okay, as you can see, most of the men were between 30 and 50. Makes sense because these are the people that are probably doing the most like construction-y type stuff around their house. Because when you get in your 60s and 70s, you get a little old. And when you're younger here, like these males in the teens and females in the teens, they were drug in by their parent. They're not probably there for themselves. You know what I mean? The 20-year-olds, yeah, just maybe got a new apartment, needed something for their new apartment or whatever. But you can see that the majority of the people are in this homeowner kind of age range where they're doing home improvements, repairs, maintenance, all kinds of fun stuff. See, what else did they want us to do? That's all they wanted to just do. Okay, but not too bad, even though they were completely out of order. Okay. Why don't you guys try this one? Now, oh wait, well, let me remind you guys of something though. When you're doing a 3-digit stem and leaves, the centers, we start at 15, well, 14. Okay. When you have a 3-digit number, your stem is 2 digits, and then your leaf is 1 digit. If you have a 4-digit number, your stem is 3 digits, and your leaves are always 1 digit. So your stem can get bigger. So it can be, the stem is 1, 2, 3, 4 digits, but the leaves are always single digits. It's always the ones. If you have decimals, then your stem is the whole number and your leaves are the decimals. Like if you have like 1.2, 1.3, 1.4, you'd have a 1 here, and then you'd have the 3, 4, you know.
So when you only 1 digit, you look at that.
Yes.
So can you have like a 13.5 stem going on from that, 13.6 stem going on?
Yes, you could. Yeah. Yes. Okay, so why don't you guys just try this one, and then we'll go over it together in a second. We want to find the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 numbers. So the median is in between the two 11s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median is between 168 and 170. So the median is 169, right? And then the mode, 155. And over here, our median, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we'll go to 11 again. So 3, 4, 5, 6, 7, 8, 9, 10, 11. And here's 11, so we're between 162 and 177. So I have to do 162 plus 177 and divide it by 2. Okay, so 162 plus 177 is 339, divided by 2 is 169.5. And then the mode, okay, so what can we conclude from the distribution? Boys are taller. That's what we can conclude from this distribution. The boys in general are taller. Now there are some tall girls, and there are some girls that are taller than some boys, but in general, the boys are taller. By, on average, like it looks like maybe half an inch. Well, not an average. Of course, the median is half an inch difference. But it's pretty close, yeah. Any questions about the two-sided stem and leaf plot? Not too bad? Okay, moving on. Double bar graphs. You remember bar graphs and histograms? Histogram. Or sorry, bar graph, histogram. Yes? Okay. Double bar graph has 2 bars on the graph. We compare data with categorical data with double bar graph. So here's how it looks. In the bottom, we're going to do an R for racquetball. I don't want to do red. We're going to have an R for racquetball, a B for basketball, a V for volleyball, and an S for swimming. Okay. Up the side, we have numbers 1 through whatever. So I think I'm going to go by 2s if I can. 1, 2, 3, 4, 5, 6, 7, 8. So I can. Okay. There are 6 girls that play racquetball. 1, 2, 3, 4, 5, 6. And 3 boys that play racquetball. 1, 2, 3. That's a double bar graph. You put both bars for the 2 categories right next to each other, or for the 2 groups in the same category touching. Okay, so, and then you have to put a key off to the side. And I probably should have done the girls red and the boys blue, but you know, I didn't, so. Okay, you have to have some sort of key off to the side so I know which group is which. And you want to use either 2 different colors, or you can use 2 different patterns, like one is just solid and the other one has like lines, stripes, or whatever. Okay, so then we have racquetball. That was racquetball. Basketball. There's 3 girls that play basketball. 1, 2, 3. And technically these should be the same width and all pretty, but it's very hard to do on here. 6 boys. So 1, 2, 3, 4, 5, 6. Just the opposite, yeah. Volleyball, we have 5 girls. 1, 2, 3, 4, 5. And 5 boys. Okay, well that one's easy. And then for swimming, 7 girls. And 8 boys. Okay. So that's a double bar graph. We can easily look at this and say something along the lines of, well here, this one, there should be an either. They're asking which 2 sports would be most equally liked by both boys and girls? Volleyball and swimming. Yeah. You could ask, like, which sport do boys like a whole lot more than girls? Basketball. Which sports do girls like more than boys? Racquetball. It's really easy to answer questions like that at that point. But there's only a 2-person difference in swimming, and volleyball is exactly even. So like just looking at this, if you're picking 2, I'd say swimming and volleyball. If you want it to be equally liked by both. Red, yeah. No, you're comparing the 2, yeah. So double bar graph's pretty. No, we're not doing double histograms. We're doing double bars, which is categorical data, but comparing 2 groups. Like, not really, because the histograms are touching. Yeah, it doesn't really work very well. Okay, so here we have academic math and advanced math. And we have the years is going to be our category, and then we have our numbers here. So we have to do 2007, 2008, 2009, and 2010. Wow. Or 2101. And then we have between 61.3 and 86.8. So I have to figure out how to break this up. So I have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I have 20 spots. And 86.8 minus 61.3, which is this, 50.9, is 35.9. I was going to go by twos because I've got 35.9, but I've got 20 spaces, so I could do 40 if I do by twos. So I'm going to start at 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 2, 4, 6, 8, 80. Okay? And we have to make some kind of judgment calls here. What color do we want advanced math to be? And academic math? Green? Okay. All right. So what we're going to want to do, 61.3, this is 61, this is 62, so 61.3, or sorry, 60 and this is 62, 61.3 is going to be kind of like halfway in between. And I'm going to go ahead and make this too wide if I can fit it. And then 74.7, here's 72, 74. So, you know, we're almost to 75, so I'm just going to kind of eyeball it, right? I can't make it exact unless I make 10 marks for every one, which would make it huge. 2 pieces of paper to make this graph if you did that, right? So you just eyeball it. Do the best you can. And then we go to our 2008, which gives me the 67.9. So here's 60, 2, 4, 6, 8. So almost 8. And 80.3, guys, shh. I'm recording. 80.3, so here's 68, 70, 72, 74, 76, 78, 80. Bar graphs are nice because you get to color. Bar graphs are nice because you can make them on Excel. And it'll color it for you. Exactly. I need to fix the bottom though. 2008. Okay, 2009, I have a 50.9, so that's going to be like, I'm just going to, right there. And then 86.8. So here's 80, 246.8. Yeah, there's a big difference in the 2009 groups of advanced versus academic math. That was an off year for academic math, I guess. And finally, 2010, I have a 67.3. So here's 60, 2, 4, 6, 7.3. And 81.5, so 68, 70, 72, 4, 6, 88, 80, 1.5. So no problem with making these, right? Oops. These are the grades, the average grade for her classes. In general, which students do best? Advanced math. if you're looking at this, would you say that she has improved her class instruction in academic math? Well, these are just about equal. Huh? I don't know, but I would say in general, it looks like yes, she has improved her instruction for advanced math in general, but not for academic math. It's either not really changed or, you know, we have this big tank. So I would just say that in general, she has not improved her instruction for academic math, but she has for advanced. Any questions on that? Okay. You guys get the, do we need to make another one or you could? Good. Okay. Done. So, your homework tonight. Reading a lot.